This is a discussion of RTLSDR software-defined radio. I am WB9TH. You can contact me for additional questions at this address. A RTLSDR software-defined radio uses direct sampling, which means that it's a digital technology which samples the RF signal as it comes in and converts it into an analog signal. It uses quadrature detection and is also called 0IF and can be used as a pan adapter. A little history on the RTL2832. This is the device that's used in this technology to produce SDR. It was manufactured originally by Realtek Manufacturing Company and was introduced as a digital TV USB device. Some folks got a hold of the device and found that you could hack it and write software for it. A couple of popular HDSDR software is used by amateur radio operators and also SDR Sharp. There are many other applications that are available online for these RTL2832 devices. It can be used with a device called an up converter. That would take the original USB device, which is a VHF UHF device, and convert it with up conversion to HF operation. In this mode, there is additional noise and jitter introduced by the device. Another mode is a driver which is produced for quadrature detection and is a simpler, more direct way and a purer way of obtaining an SDR. Okay, to use it as a pan adapter, all you need to do is take the unmodified device off of eBay and connect it to your IF output of your transceiver, such as a Kenwood or an ICOM that has an IF output. Some of those IFs are, for example, 69 megahertz. So with the unmodified RTLSDR device, you can directly visualize spectrum in the HF band. It uses the preselector of the radio you're using to filter and eliminate a lot of outside bandwidth that you don't want to see on the SDR. Any of the RTL-SDR devices must have a tuned antenna and an external preselector, or an ATU, an antenna tuning unit, is okay to use as a preselector with any of these devices. But if you don't use it, you're going to get a lot of AM signal interference, you're going to get a lot of FM broadcast signal interference, and some TV interference as well. So that's what you need to do to get satisfactory operation out of any of these RTL-SDR devices. So if you're a SWL, a shortwave listener, you may not know about this kind of a device. This is a preselector. It's made by MFJ, and it allows you to filter what's coming from your antenna to an SDR device. It's a very effective tool, and it'll provide good operation for you. If you are an SWL operator or a ham radio operator with, say, an HOA that keeps you from having an antenna outdoors, you can use a device like a magnetic loop antenna and get very good performance. I've got one on my YouTube channel that I call the Mystery Magnetic Loop Antenna that I've come up with. And basically it gives you a very directional antenna of low noise. And with the design I have, here's the spectrum results off of the analyzer that show it below 1.2 to 1 all the way across the entire 80 meter band. This is the RTLSDR device that I make. I've sold about 120 of them, and it has a HF input for basically near DC to 30 megahertz. It uses a quadrature driver circuit with a low noise amplifier and yields a performance of some of my customers have said is close to an ICOM receiver in sensitivity. It also has a TNC connector for the VHF UHF. I'm forced to use a TNC connector because a HF type UHF connector will not pass the upper 1.7 gigahertz frequencies. This is the TV dongle that you can buy off of eBay for about $15 to $20. And this particular one uses the RTL2832 chip made by Realtek. And the earlier versions used a crystal to set the frequency of operation for the chips. The crystal doesn't really drift very much, but you have to use a correction frequency to get it directly back on frequency, which is used in HDSDR. There is a window you can pull up and set the frequency correction so that it's smack dab on frequency. It doesn't really drift enough to be noticeable in most instances. This is the motherboard and the RTL device that I have in my RTL SDR unit. And in this particular application, I've selected a TV dongle that uses a temperature controlled crystal oscillator, and it's always dead nuts on frequency. You don't have to worry about any frequency correction. I use the quadrature circuit to directly drive the RTL2832. There's no up converter involved, so you're eliminating all of the noise and phase shift and jiggle that you get with the up converter. It also has a low noise amplifier that increases the sensitivity of the device to about a plus 19 dB. If you were to use an up converter, it would come in on this antenna path and go in through the tuner on board. So you'd be talking about all of the electronics in the up converter plus the electronics in this tuner, and then going into the RS2832 device. So you've got great layers of additional noise injection with the up converter device. So suppose you have an older generation of transceiver like the KWM2A. You can step into the world of SDR technology by using the IF output of the KWM2A and running into the SDR device, which will give you the spectral display that you're looking for. We'll discuss that next. Here's a display of an AM signal. It's 820 and gives you a RF display and the audio display again. And you can see a signal here on 860. There's the spectral display of an FM broadcast station operating at 88.5. And what you see here is the FM carrier. Over here in the audio section, you can see the pilot carrier of pilot signal of 1900. And you can also see the SCA bands, upper and lower, which carry, for example, elevator music and other advertising. I've done a split screen here to show you the effect of using that antenna tuner, Preselector. Without it, you're going to get all sorts of broadcast band interference. The signals will be there, but you'll have so much interference from other powerful stations, it will not allow you to have a good, clean, operable signal. With an ATU, you'll be able to define every individual signal and carrier. Another thing I'd like to point out here is why would you just normally want to use an SDR? Because it's a spectrum analyzer. It shows you everything that's on that band. So if you were not using one and you're just tuning up and down the band with your tuning knob on your radio, there are going to be times when you're going to be missing conversations because you won't know that they're there. It'll be a hit or miss operation. So that's another advantage of using a software-defined radio. I provide a manual, step-by-step, with graphics to show how to set up the RTL-SDR, and also provide email support for the product, because there's a lot of things that are difficult for a first-time user to set up to achieve the proper operation of the device. Another advantage of the HDSDR software in using a SDR is that you have additional filtering capabilities. You have noise reduction, noise band filtering on RF, and a very important feature, which is the notch filters. Here is a signal that's selected, and you can see interfering carriers, some people tuning up, some other QRM in that signal. In the graphics display, it produces tone and noise, which you can get rid of with the notch filter. So I'll select these two noise bands and eliminate them. All right, now I've applied the notch filter. It's a matter of putting the cursor on the interfering signal and clicking on it. You can also use the scroll button on the mouse to widen the bandwidth of the notch out. This allows you to hear good, clean audio without interfering signals. You can also adjust the upper bandwidth from 3000 hertz audio response down to, say, 2000 hertz and eliminate an overlapping signal of somebody who is coming in just adjacent to where you are tuned. So those two filter techniques allow you to provide excellent reception with very little interference. SDR devices will allow you to use additional software. This is FL Digi, and we're set for Olivia, and we're taking that Olivia signal, which is a very low level signal, in the noise, and producing a usable text display. You can also use DSD Plus, which is a conversion from digital to analog. That'll operate with HDSDR and other SDR software. So you can do digital as well as Olivia and some of these other forms. PSK31 is a good example. Here's an example of a screen display setting up pan adapter device on your transceiver. You start out by selecting off of EXTIO, or in later versions of HDSDR, you select the SDR button over here, and you have the direct sampling set to disabled. You select the IF frequency that's coming out of your transceiver. In this case, it's 69.5. And you can then widen the spectral display out so that you see everything that's in there. That is basically the whole band. Say you're looking at 7 for a 40 meter signal, 7.20 megahertz. Everything in that spectrum is compressed down into that IF strip. By adjusting the spectrum display here, you are going to broaden that out so you see the entire spectrum. If you're using YouTube to visualize this discussion, you can do a pause, and on a Microsoft PC you can do a function print screen, and it'll capture that screen that we're showing right now, and you can then put it into Paint by clicking on Paint and doing a Shift Insert and then saving that file. It'll give you whatever you see on YouTube as a JPEG file. I mentioned DSD Plus earlier, digital form of receiving signals, and you can go to RTL-SDR.com and pull up instructions on how to use DSD Plus. Here's an example of using FL-Digi in the PSK31 mode. Very effective. Down here on the audio display of both FL-Digi and also of HDSDR, you can see the characteristic display of the PSK31 signals. And look how many of them are stacked into this one bandwidth of the audio spectrum. Okay, so that's the quick view of RTL-SDR. So if you have any additional questions, you can contact me at this email address. Here is another add-on for the SDR device. It's called EasyPal, and it's a slow scan method of sending photographs. And it's a very effective tool, very popular when the bands were good. This is an image that was sent over the HF frequency, and it gives you the detail about who sent it, their call sign, the received signal strength. You can send text along with it. A lot of fun. This is a example of photographs that I have received on EasyPal. That was one that I sent. There's an air conditioner installed in the car. I received that signal. The TSS Saturna. Broadcast band AM transmitter. So that's about it.